So we're going to look at another model for multiplying fractions. So the first model was using language or of to do that. This one we're going to look at using an area model. So when we do multiplication, our main model for multiplication is area. Length times width equals area. So the answer to multiplication is area. So we're going to use the area model to help us understand fraction multiplication. So first we're going to start off with this 1 by 1 square. Okay, and we're going to imagine this is a number line. Okay, so here's 0, there's 1 along the horizontal, and here's 0 and there's 1 along the vertical. And 1 by 1 square is going to give us an area of 1. Now it's really important that you understand that this 1 by 1 square now represents our 1 whole. Okay, this represents our whole. So if I were to shade half of this, okay, that represents 1/2 of our whole. Okay, so this is going to be how we're going to determine the answer to our fraction multiplication. So what does this fraction multiplication then look like? Okay, well, what does 1/2 times 1/4 look like? So what we're going to do is we're going to express 1/2 along the horizontal. So 1/2 ends up right here. Okay, so this line represents the 1/2 line. So I'm going to take this length of 1/2 and I'm going to times it by 1/4. So if I go along the vertical, so that's my length. So I need to find my width along the vertical. Okay, so 1/4, these are 4 equal pieces. So my 1/4 is going to be that line there. So again, it's really important to understand that we're actually using the length here as 1/4 and the length here as 1/2. So the area, my answer to this fraction multiplication must be this area in here. Okay, so that area must be the answer to multiplication. Length. Okay, so there's my length this way. Length 1/2. My width 1/4 is going to give me an area of that little blue square. Now, what fraction of the whole is that? Well, we know that the big square represents 1 whole, so I'm just going to highlight that. So this is 1 whole. So that blue square represents what fraction of the whole? Well, it is clearly 1 out of 8 pieces. Okay, so the answer must be 1/8. So how many rectangles make up the whole? Well, there's definitely 8 rectangles that make up the wholes. There's only one rectangle that makes up, this little one here, makes up the part that I want, the shaded part, which is the area that I want, which is the actual length and width that I want. And from this diagram, it's clear that the answer has to be 1 out of 8. Okay, and the picture does not lie. 1/4 times 1/2 gives me 1 fraction out of 8 fractions whole. Now, if I just go back, that was my answer here as well when I used language. Okay, so 1/2 of a 1/4 fraction, yeah, that was 1 out of 8. So we have both methods confirming that this is in fact true. Okay, and we should be fairly confident with the area model because the area model we use a lot in math to confirm our multiplication facts. Okay, so this is a good way to do that. So we can do some practice here. Okay, so we have a 1/3 fraction times a 1/2 fraction. So let's color code this a little bit. Okay, so 1/3. Now it doesn't matter if 1/3 is along the horizontal or vertical. I'm just going to make it along the horizontal. So I'm just going to divide it up into 1/3 here. So 1/3 is right there. And this is the length 1/3 that I want. Okay, so I put it on a number line. Okay, now I want you to understand a number line, but really it still means that that length is 1/3. And I need a 1/2 length. Okay, the 1/2 length I'm going to put along the vertical. If 1/3 is along the vertical horizontal, 1/2 has to be along the vertical. So there's my 1/2 line. And this length here represents half. So length times width, the area that I want is this area in here, the length times the width area. So what is that area? Well, that area in terms of the whole, well, the 1 by 1 square represents a whole. There's 6 pieces that make up this whole. So then that must be my denominator. Okay, must be out of 6. And there's only one of those 6 pieces that are shaded. That's the area that I want. So 1/3 times 1/2 gives me the area of 1/6, and my diagram confirms that. Okay, we can do the same thing here. What if the numerator is more than 1? Well, 3/4. I'm going to do along my horizontal. Okay, so there's my 3/4. I'm going to maybe do that one in green this time. Actually, I keep it consistent. Let's do that, the horizontal in red. Okay, so the 3/4 is right there. Okay, so this length here represents my length piece. And I need the width piece of 2/5. Okay, so my 2/5 piece, I'm going to do along the vertical, so I have to do this in 1/5 pieces. So I'm going to go 1/5, 2/5, 3/5, 4/5, 5/5. Okay, so 2/5 is right there, so it must represent this length here. So the number of pieces that I have shaded then, it's got to be this rectangle in here. So it's got to be this piece, all the way to the 3/4 line. So there it is. There's my answer. There's the answer to 2/5 length times 3/4 length. Okay, just going to make sure that that's nice and clear. 3/4. Okay, 3 out of 4. So again, what fraction of the whole does this represent? Okay, so if I take a look at again, my 1 by 1 square represents my one whole piece. There are 4 groups this way, 5 groups this way, so there's 20 pieces that make up my whole. And that makes perfect sense because I have 4 groups of 4 that make up my whole this way. I have groups of 5 that make up my whole this way, so that makes sense that I have 20 pieces that make up my whole. Well, what about the shaded part? Well, I've got 1, 2, 3, 4, 5, 6. There's 6 pieces that make up what I'm counting, those 6 pieces there. And if we have 5 groups this way, we actually have 2 groups that we shaded this way, and we have 3 groups that in fact, this is just grouping, so we can just do 2 groups times 3 groups to get our 6 groups of shaded area. Interesting. That looks like I can just multiply the top times top. 2 groups, 3 groups gives me our top. 4 groups this way, 5 groups this way gives me my whole, which is the bottom. I wonder if that worked here. Well, the 1 times 1 on top gives me the one piece that I shade. The 3 groups this way and 2 groups this way gives me my 6 pieces that make up my whole, and that's my denominator, 3 times 2. I wonder if it worked here. Well, the 4 pieces this way, 2 pieces this way make up my whole, or my denominator, 8 pieces. And that 1 piece shaded this way and 1 piece shaded this way give me my 1 piece that I'm counting in the numerator. There seems to be an easier way to do this. I think we can use maybe this rule. I think it looks like we can do top times top. And I think we can do along the bottom, bottom times bottom. This seems like an easy rule to follow. Okay, but we got to make sure that it actually makes sense. It seems to make sense because the bottom represents the number of pieces that make up the whole on the square, and I broke up that square into 4 groups this way to make up my whole, 5 groups this way to make up my whole. Yeah, that makes perfect sense to get 20. Top times top, well, the top represents the number of pieces out of 5 I shaded here, and the top represents the number of pieces out of 4 I shaded here. Well, if I have 2 groups this way and 3 groups this way, I should have 6 groups in the middle, or 2 times 3, or top times top. That makes sense for the pieces I shaded. So this rule of top times top and bottom times bottom seems like there's good reason it works. And in fact, we could even think of it another way that we understand fractions. We know that fractions are all about times and divide. And really it's just top is times, and we keep the bottoms for divide. And we group the bottom divides together, and we group the top times together. That seems perfectly reasonable to do. In fact, that makes sense. And this then becomes a very easy way for us to be able to do fraction multiplication if we understand when to apply this and why we apply this.